Hi all, I'm Soma, and today I'd like to share my thoughts on the Armattan Chameleon. First off, a huge congratulations to Jason Hay, Chris from Armattan, and the whole community who played a part in delivering this groundbreaking design. It takes something truly exceptional to rise above and stand out in today's crowded FPV marketplace. And it's not often a frame offers something so fresh, unique, and generates a buzz like the Chameleon. I've seen many extremely enthusiastic reviews professing comments like, the best frame ever, period, and I agree with their enthusiasm. The Chameleon implements so many forward-thinking pilot requests and new trends, all in the one package. The modern drop deck frame minimizes dead space, is way more compact, and lowers CG. The huge weight saving and convenience benefits of a unibody baseplate, the outstanding aesthetic combination of carbon and custom CNC alloy, the built-in independently adjustable tilt for both flight cam and HD cam, neatly cut and lightweight padding included for the LiPo and HD cam, and now an ultralight and extremely convenient antenna mounting solution. In overall weight, the frame beats comparable frames by around 20 grams, but that's only half the story. Having the built-in GoPro mounting capability pushes it relatively another 15 to 20 grams ahead of frames that lack a built-in GoPro mount through not needing a 3D printed add-on. Outdoing that even further by also offering the added convenience and functionality of being easily and quickly angle adjustable. It also has the advantage that if you alternately fly with and without a GoPro, it's immediately lower profile once the HD cam's removed, and not a pain to remove the GoPro mount when flying free. So much thought and energy has clearly gone into this design. Overall, the Chameleon is the sleekest freestyle quad yet, and fully deserves every success it is currently enjoying. As a quick product overview, the packaging is professional, as you would expect from a high-end manufacturer like Armattan. The main bag contains the unibody baseplate, PDB kit, secondary parts bag, and instruction manual. The lightness, minimalism, and convenience of the unibody design immediately makes itself obvious. The version shown is relatively stiff, but the newer quasi-isotropic carbon versions now shipping are even more so. The carbon cutting is among the best I have seen, with no chipping or sharp edges, and the carbon is exceptionally clean, straight out of the packet. The secondary package contains the secondary carbon parts, CNC alloy parts, die-cut foam pads, fastener pack, a strap, and stickers. The PDB kit contains the PDB itself, adhesive vibration dampening pad, XD60, wires, heat shrink, and strain relief. The PDB has 5 and 12 volt regs and plenty of copper. Last, and certainly not least in the main pack, is the professional step-by-step instruction manual. I cannot stress enough how important it is to have a clear, concise, and easy reference such as this included, and this is another area in which the Chameleon sets itself above the competition. Opening up the secondary parts package shows the secondary carbon, CNC alloy, and die-cut foam parts. The carbon top plate, the flight cam side plates, and the GoPro top plate. Again, the cutting quality is superb. The CNC alloy front uprights, GoPro support adjustment rail, and rear SMA bulkhead. Again, the machining quality is top notch. The die-cut foam LiPo pad and GoPro pad. The stock steel fasteners keep retail costs down, and thanks to the design's minimal fastener requirement, still comes in lighter stock than other frames that are already utilizing the weight-saving advantages of more expensive hardware. Of course though, I couldn't leave well enough alone and replaced all the steel fasteners with alloy. This picture shows how minimal the Chameleon's fastener requirements are at the extreme, down from 24.2 grams to 6.3. This particular fastener specification is specific to the upcoming 2-hole flight cam side plates, designed to mount the flight cam with only 2 M2 screws per side. The alloy screw selection shown includes 2 screws per motor and flight controller hardware. It is truly impressive just how exceptionally minimal the Chameleon's fastener requirement is. Of course, the CNC alloy weight of 24.5 grams should also be taken into account, as in this instance they occupy a middle ground between the traditional carbon and fasteners design. Even so, completed, the stock Chameleon beats its competition in weight savings, while having considerable upgrade potential to expand that lead. Moving on to assembly, and beginning with the front upright sub-assemblies. Right from square one, it is an inspiration and pleasure to work on the Chameleon. Appreciating the engineering itself is reason enough to own the frame. First, the two side plate sub-assemblies are completed. Note that at this stage the original camera mounting should already be installed. I initially pursued this build as if using the forthcoming simplified side plates, but more on that later. Adding the carbon GoPro top plate ties the two side plates together. As with many such assemblies, it is worth slightly loosening all related fasteners so they can all be torqued in unison, uniformly taking up the slack between parts. Here I found it advantageous to loosen the side M3 screws to facilitate tightening the more delicate M2s, and then progressively tightening the whole assembly little by little to fully seat the top plate. Normally, the camera assembly would also be part of this process. It is at this stage I found a challenge in using the alloy M2 screws. While the stock M2x10 steel screws threaded in without incident, the alloy screws were tighter in the threads and needed preparation so as not to shear when tightening. This was accomplished by running a stock screw in and out to clear the thread, then blowing away any debris. Then, a lightly greased alloy screw was gently worked in little by little until seated to work the threads in. This was only required for the relatively delicate M2 alloy screws. Steel and stainless steel work without issue. Crazy and Slipstream went for stainless steel M2s, and I think this is probably the best balance, being only 2.6 grams heavier at 4 grams than the delicate alloy at 1.4 grams. The completed front assembly then slots onto the main plate, and the M2x10 screws fasten it in place. Regardless of material, M2s do require a higher restraint of oafishness than M3 and should never be over-tightened. They are well strong enough in this application, but care should be taken to avoid user error, as shearing a screw here will prevent the removal of the front assembly. The CNC alloy rear SMA mount is next to assemble on the base plate. A really nice touch here is the machined-in slot to locate the SMA bulkhead mount, whether standard straight nut type or right angle as shown here, and prevent it turning when tightening the outer nut. Installing the carbon lipo plate completes this stage of assembly. It is worth noting that I've shortened some of the recommended M3 screw lengths in the alloy replacements. The M3x6 on the lower flight cam plates down from M3x8, and M3x6 countersunk in the rear down from M3x8. Overall, the Chameleon is an easy and pleasurable build. It's the simplest frame to assemble and maintain I've ever encountered, with only two tools, 1.5 and 2mm Allen drivers, required to assemble the frame to the stage shown, ready to receive motors and a flight controller. I especially like the totally independent front camera sub-assembly and the ease of removing the lipo plate for quick access to electronics. The weight at this core frame stage is impressively light at 113 grams. The GoPro mount angle adjustment is incredibly easy to use. Simply loosen the top two side screws and adjust. Intelligent, functional design. The body is super compact, and the drop deck minimizes wasted space, yet at the same time still protects lipos by maintaining a position above the prop plane, and no sharp edges in front of the lipo in a crash. I originally assumed there would be flex in the top plate given the relatively long, unsupported span, but it distributes force through the frame structure very well, and is much more rigid than first expected. I've seen its reliability proved time and again in crashes, and it seems at this stage to be fully up to the task of dealing with the lipo's inertia. Same for torsional rigidity. The structure is very strong and no signs of flex. There is an amount of flex in the unibody base plate I currently have, but the new quasi-isotropic carbon base plates are currently shipping, and the 45-degree fibers significantly firm up the arms. Even so, the performance I have seen from the original Chameleon in flight is exceptional. There are relatively few details that need attention on the Chameleon to avoid sharp edges compromising straps. The first is where the lipo straps round the upper deck under strain, and the other is where the GoPro straps pass under the alloy sides and/or carbon if you run a lengthwise strap. Onto the flight camera mounting. As mentioned earlier, there is an option to forgo the stock mounting in favour of two screws in either side of the newer camera cases supporting this mount. This will significantly lighten and simplify the assembly. After first encountering this method in Slipstream FPV's builds and being suitably impressed, I originally intended to go with the same mod myself. I am sold on the 2-screw method being superior, but after reviewing the stock mounting, I was so impressed by the thought that had gone into the design, I decided to build it stock, albeit replacing the knurled thumb screws with M3x6 alloy buttons. This configuration of parts comes in at 2.2 grams. The design is based around the 3D printed TPU camera holders, which should have a side benefit of dampening vibrations in a CMOS camera, should that ever be an issue. They suit the standard HS1177 style case shown here with weight reference of the camera. Stock, the press nuts are inserted into the TPU parts and then the TPU installed in the side plates. I did have some trouble with the included press nuts. The narrower, knurled end slipped diagonally into the slot and the screw head crept in the slot when tightened due to friction on the sides of the slots. I remedied this by adding a thin spacer as a washer under the screw head and replacing the press nuts with a 5mm diameter standoff. The ideal spacer length would be 27.5 to 28mm, matching the interplate spacing, which could be done if custom made. Cutting down a 30mm standoff would probably yield the best result. With these slight mods, the stock camera tilt was way more stable and much easier to adjust perfectly. It added a little weight, but you can see the additional side benefit of the structural bracing it adds to the front section. Finally, the camera was set to the max tilt angle for the GoPro if used, and the GoPro mount returned to its retracted state. The weight of the frame at this stage is just over 130 grams, including the 14.3 gram flight cam, so an impressive 116.5 grams, including foam pads. Again, other than the small camera tilt mechanism modification, the frame was a straightforward and pleasurable build. The only issues I encountered were from my own messing with the original spec, replacing fasteners. This is well worthwhile weight-wise for all the M3 hardware, especially with button heads, which offer the greatest saving, but I do think the M2 alloy is possibly pushing it too far. But I always like to start at the extreme and work my way back only when necessary. Shown here, ready to receive electronics, the FC mount screws will most likely be changed to M3x12 buttons with a 3mm plastic spacer under the lower electronics board to the standard standoff above. I'll be using the awesome new Motolab Typhoon F4, 2-board, PDB, FC, VTX, OSD stack on this build. Other option would be to use a 4-in-1 ESC with a Tramp VTX, but for convenience and versatility, I'm really looking forward to running Moto's Typhoon combo. Whatever option chosen, the Chameleon is up to date and ready for these more modern, compact and lighter solutions out of the box. Excitingly, we received the new prototype antenna mounts just in time for this video. This part is Crazy FPV's idea, and he, Slipstream FPV, and I jointly designed the part. Armattan had them produced in an impressively quick turnaround, testament to how agile and responsive he is to community involvement. We have no vested interest, business or otherwise, in the part. It is purely a contribution back to the community. The part is 4mm thick carbon, weighing in at 1.15 grams. There are 2 milled channels for 3mm OD antenna tubes, orientated at 90 degrees for optimal reception. The part mounts under the rear underside of the frame. Being 4mm thick carbon, the M3x8 screws are replaced by M3x12s. The channels intersect the screw holes for an interference fit with the screw threads. The channel depth is less than the tube's outer diameter to compress the tubes when tightened. The pre-assembled parts are held with enough firmness to conveniently hold together, yet still retain enough tolerance for easy assembly. When pre-tensioned to just touching the body, final adjustment of the tubes can be made. When fully tensioned, the tubes compress, forcing the sides outward and harder into the screw threads. The combination of forces locks the antenna tubes firmly and also has a resistive thread locking effect on the screws as an added benefit. The compression is not so great, however, that the antenna itself is crushed, potentially compromising its insulating material. If needed, the tubes can be lightly heated and formed in towards the body for more protection of the antenna leads. The result keeps the antenna tubes clear of the body for improved reception, yet they're still in a relatively protected zone between the rear arms, reducing the likelihood of them being pushed into the props from impacts. In wrapping up, for transparency and openness, I have no business or financial association with Armattan Quads in any way. This frame was a personal gift from my good friends Crazy FPV and Slipstream FPV, who are sponsored Armattan pilots. Regardless, it was given to me to personally fly with no obligation whatsoever. This review represents my honest and personal opinion. Quite simply, I was so personally impressed with the design it inspired making this video. In all fairness, no design is ever perfect in every regard, and it is not reasonable for anyone to expect it to be so. It's always a particular balance that the designer and pilot choose to prioritize. In that regard, and in the spirit of a well-balanced review, I would not say the Chameleon is the best frame for every possible purpose. I think, for instance, there are better racing frames with the current trend towards Hyperlight. The Pyro Flip Hyperlight Floss and Armattan Race Prototype are great examples, but in my mind, it is the greatest challenge in design to satisfy the widest range of applications, and it is succeeding in this hardest of challenges that I feel is the Chameleon's greatest success. For freestyle and everyday general flying, especially if you're looking to carry a GoPro for HD footage, the Chameleon raises the bar in a way more modern, truly next level design. I highly recommend doing yourself a favor and experiencing everything the Chameleon has to offer.